Good morning. Thank you very much for coming to this awesome event. Oh, yeah, that's one of the great things, right? That sometimes you got this problem. But today we're going to talk about securing secrets in the GitOps era. So basically, I'm just going to show you some techniques that you might adopt or not if you've been managing secrets in a way that you think that it's okay. It's fine for you, it's fine for me, but I will explain you here also some of the problems that you might find. So, my name is Alex Soto, my tutor is Alex Soto B, my email is soto@redhat.com, I'm the co-author of these books. If you've got any question, I know that we've got some time after the session. I will be around the venue after the session as well, so you can just approach me. And if not, you can use Twitter or email, it's no problem. First of all, I need a volunteer. Any volunteer? I need to come here to the stage. So I need to be a volunteer. No volunteers. No volunteers. Come on. Okay, come. Then we're going to... good. Now, we're going to talk about secrets, okay? You can see that all the cards are different. Yeah? Good. Yeah. Okay. Then I'm just going to, ripple the card. Okay? Wait. You say me stop, and I will stop now. I will stop when you say, okay? Stop. Here? You're sure that you want in that place, right? Here. Yes. Here. Oops, sorry. Here. Yes. Yeah, here? Yes. Sure? Okay, just, you see the card, okay? Yes. Yeah, you will pick it. The card, this camera. Yeah, wait. You take this, okay? You can come here. And I'm going to just put, so everyone knows exactly which is the card. Wait, put it here, the camera. Okay, I'm just going to put here so I cannot see anything. Okay, here, just showing the camera. Okay, everyone sees the card? Yeah? Okay, just put it around here. It doesn't matter. Okay, now, I know that all of you have a secret, right? I don't know the secret. But watching you, I think that is the Three of Hearts. Three of Hearts? It was the Three of Hearts? No? Yes? Yes, it was Three of Hearts? No? Okay, so all of you know how to keep a secret, okay? Just don't tell me which is the card. Just congratulate because you know how to keep a secret, okay? So now I'm going just to cancel. Yeah, just big applause. Thank you very much because now you've got a secret and you know how to keep a secret, which is really, really great, right? I'm going to continue with my talk because, as I said, we're going to talk about secrets. And what is a secret? Okay, as you've seen now, a secret is a piece of information that is only known by one person of a few people and shall not be told to others. In this case, all of you have a secret, but not me. It's like, the inverse of the example, but that's fine. And in this talk, we're going to talk about the secrets, but not let's say, the secrets that your users might have in your platform, not about users and passwords to access to your platform. We're going to talk about secrets that are used, for example, to access to your database, the username and password to access the database. Your application needs this secret, or to access the Kafka cluster, or whatever. And this is somehow annoying, because I will stay there like every 5 minutes, because I don't know how to just stop it. Okay, so let's talk about security. Let's talk about layers. At the end, security, it's about layers. It's about, adding some kind of layers. There is no 100% secure system. If someone tells you this, they are lying you, they are not telling you the truth. So the only thing that you can do is just add a layer of protection, and then another layer of protection, and then another layer of protection, and so on and so on. So if one of these layers is broken by an attacker, you've got another layer protecting the secret. Okay? Oh. Yeah, it was that like, right? Yeah, okay. Yeah, it's a secret, right? You can see that secrets at the end, needs to be protected, okay? So let's talk about secrets. And today we're going to talk about two kind of ways of managing secrets. One is the easy one, okay, in the part of the GitOps with the Barbie stuff. And then other ones, which is securing the secrets inside Kubernetes, which is somehow harder, right, for this thing of Oppenheimer. So first of all, what is DevOps? What is GitOps? Just a quick introduction. DevOps, it's just we know that it's like a methodology that involves all your organization to make you deliver new versions of your application, your service faster, okay? Because at the end, when we try to deliver something to production, it's quite hard. You can see here all the, okay, all the developers, this is the application, all the developers here saying, hey, we want to go to production, we've created a super nice new feature, let's go up. Oh, and then there is this one. Maybe it's the tester, right, saying, no, we still not been super, so it's not been tested enough, let's wait. Then there is this guy. Probably it's the architect, right here in just, in the application. Hey, I'm here just, I've architected the best application possible. Oh, and this one? It's the DB admin. Sure, it's the DB admin, right? So, and the problem is that this happens once, and then after 1 month happens again, and after 1 month happens again. And okay, it's not the best way, right? It should be something like this, a small thing that it's really smooth moving to production. So for this reason, I said that it's a really good idea to adopt DevOps. And of DevOps, we can just transition to GitOps, because at the end, we can think that GitOps is like an implementation of DevOps, okay? It's not like that kind, but it's a good summary, okay? Basically, in GitOps, everything is in Git. So it's not just the source code of your application, but also all your infrastructure code, how to deploy this application, the pipeline to deploy the application, and so on. It's in Git. Everything is, as I said, as infrastructure as code. So the infrastructure required for deploying the application, for example, we need, I don't know, a volume in Kubernetes for your application, or maybe your application requires a database and, I don't know, a distributed cache. So all these things that are required of all applications are all in as code. And finally, everything, that when we try to deploy something, all these operations goes through Git workflow. It means that I want to deploy to production. Okay, I need to do a commit and a push to a Git repository. Oh, but I've got several environments. Okay, then I can have, for example, a branch for the testing environment, a branch for the staging environment, a branch for production environment, and when we want to deploy one application from one environment to another one, we just need to merge changes from one branch to another branch. This is how GitOps works. And basically, if you are already doing GitOps, you might end up by having two repos. One is the source Git repository, which is this one. Basically, this one is the application itself. And then we've got the config Git repository. This is where we put all our manifest, all our Kubernetes manifest to deploy our applications. Okay? Then, in this case, this is an example of how Argo CD works, but Flux CD works in the same way. Basically, we've got a controller that is monitoring this Git repository for any change, and when there is a change, it detects that the change in the Git repository is different of what you've got in your cluster, in your Kubernetes cluster, and then take action. Basically, it applies this resource, deploys the new version of the application, and then starts again monitoring, okay? Probably most of you have already seen this explanation. The problem is with the secrets. Okay, you see that I've got here an application. I've got a lot of manifest, of Kubernetes manifest, like for a to-do application that I've deployed. There is the service, the deployment, and come on. Well, just and as you can see here, there is a secret, right? This is the Postgres secret. Basically, it's where we store the username and password to access the database. So my to-do application needs to access the PostgreSQL database. So I've got here my secret. And the secret looks like this: data, username, and password. And OK, you can see here that it's weird. Yeah, I probably said that it's not very secure, or at least it seems. Yeah, that's true, because basically it's in base 64. Because by default, a Kubernetes secret is not encrypted, but encoded. And you know that base 64, it's just, apply something to a string, and you get it. This string that is different of the original one, but you just need to do a decode, and you get it again, the string in plain text. So you do echo of these things, and you get it base 64 decode, and you've got the admin. So, OK, secrets in Kubernetes are not really secret, as you can see. And if you want to store it in Git, you've got some problems. So let's find a solution for this. And this is the easiest part, OK? Securing your secrets into Git. Basically, I would say that nowadays there are a lot of projects, but for me, I really love two projects. One is Seal Secrets, OK? Seal Secrets, it's just, a Kubernetes controller. So it means that it's something that is running inside your controller cluster, okay, that let you encrypt secrets, the YAML files on your local machine, and then store them encrypted in Git. And then when you apply these encrypted secrets, these secrets are decrypted into the cluster and applied. So basically, it works in this way. I've got my Kubernetes secret. You can see it's a plain text Kubernetes secret, as I showed you before. I've got seal secrets running into the cluster. And basically, I've got a CLI tool that says, hey, just take this secret and just kubectl encrypts. And what this process does is just connecting to the controller and saying, hey, give me the public key to encrypt this Kubernetes secret. So it gets the public key, and it encrypts the YAML file. And now you can see, well, maybe not, but here it's of kind secrets, and here it's kind seal secrets, and the username and password is not encoded anymore, but encrypted. So now it's something, that we cannot understand. And after that point, you can remove the original secret. We do not need any more. The secret is here, it's encrypted, and we can push to Git. It doesn't matter if anyone just reached this secret, because it's encrypted, not encoded. Then at some point, Argo CD, or we doing kubectl apply, we will apply this secret that it's encrypted. Okay, we will apply it, and basically, when we do kubectl apply of an object of type seal secret, it will just send an event to the seal secrets controller, and seal secrets controller, since it has the private key to decrypt it, it will decrypt and regenerate again the secret. So now, inside the Kubernetes cluster, we've got an original Kubernetes secret, which is applied and stored into etcd. Okay? This is one project, which works pretty well if you are used to use Kubernetes secrets manifest. But there is another one, which is external secrets. External secrets uses the same approach, if you will, more or less the same approach, as it has a control into Kubernetes. But now, instead of reading secrets from the Kubernetes secrets YAML file, read the secrets from a secrets management system. For example, Vault or Azure, and Google and Amazon has their secret management systems, and it's more or less the same. We add something into the, for example, Vault, HashiCorp Vault, and then we connect this external secrets controller to the Vault. So we configure saying, hey, external secrets controller, connect to this Vault instance or this Amazon secrets management system or wherever, connects there, because there is some secrets that I would like to consume. Then you configure this, you can see here the YAML file, and then basically it will retrieve this data, and we can even configure a polling system. So we can say every 30 seconds, connect to the secrets management systems and get if there is new secrets, and create a Kubernetes secret manifest. But you can see that, apart that this is annoying, this is something that you can see, but apart from that, here, you can see that now my secrets are never in a Git repository. They are always, in a secret management system or inside the Kubernetes cluster. So you're skipping having to manage these secrets into Git. Okay? Just keep in mind, if you're using HashiCorp Vault, which I think that it's a really popular solution, keep in mind that there is the HashiCorp Vault operator that does exactly the same thing as external secrets. So you do not need to add, another, let's say, another controller into the cluster, plus automatic rolling update. Because when you change a secret, at the end, you're injecting the secret inside a pod. So you need to restart this pod so these secrets takes effect, right? So with HashiCorp Vault operator, you've got this automatic rolling update as well. So let me show you some demo of these two projects. I've got here my cluster. I think that, it's visible. Now, I will share with you the repo later, okay? This is my secret. Okay, this is my secret. It's just a secret that is not encrypted. And then I can do kubectl script. Oh, no, minus YAML, it's wait. Seal. Let me wait, because oh, yeah. Thank you. Oh, wait. Okay. Basically, because I know, well, you can get it, but I don't want to spend so much time here, because I think that it's minus OYAML. Seal minus YAML. And this is the Postgre secret. And here, Postgre P secret. Okay, so basically, because it's minus O. I think it's minus O YAML. Now. Man. Wait. Usage. Then it's minus from file. Okay, yeah, now. Minus from file. But recur row, no. Come on. Well, that's, now it's like when you always have a shell script running it. So, yeah, it's minus O. And it's YAML, yeah, you put it correctly. Okay. Well, it doesn't, just to go fast, because I don't want to spend here time. Basically, after you apply this kubectl thing that now I can remember, just thing of the direct, now you can see here the object, which is a seal secret, so it's not a secret anymore. Okay, and you see that the username and password are not in base64, but it's encrypted. Now, I can do kubectl get secrets. You see that this secret is not deployed here. Now I can do kubectl apply minus F of the PostgreSQL secret. Now I'm just applying this seal secret. And now if I do kubectl get secrets, you can see here that there is, wait, namespace sealed example. It's here? No. What? I'm thinking that I'm in the, well, maybe not, but kubnS, select example. Well, just in case, yeah, let's try if it's this. No. Okay, kubectl get seal secrets. Okay, I don't know why now. Why is that working? Come on. You know what's, oh, no, yes, here. Okay, so, Crive, select secret. No key could decrypt secret. Okay. Okay. Well, doesn't matter. Let's forget this part, because you know what's happened. I will tell you what happened. Is that usually in the morning when I've got a demo, I just burn some Windows XP CDs for, a sacrifice for demo gods. And since today it was early morning, I couldn't do that sacrifice to the demo gods. So yeah, now they are not working. That's the thing, but it doesn't matter. Let me go to the other example, which I hope that this is going to work, which is it's the external secret. So here, as you can see, I've got the Vault. I've got Vault instance running with a secret. And I'm going to, first of all, connect the external secrets operator to this Vault instance by running the following this cluster secret store. Okay, here I'm just saying, hey, connect to this Vault instance. So kubectl apply -f of cluster secret store. I just apply it. Now I've got the connection between the controller and Vault. And now I want to configure the controller, saying, OK, now you're connected. Just get this secret and create a Kubernetes secret. And it's done by external secret. Wait. Okay, if I run it now, here is what I say. Okay, just connect to the vault. Just get the, secret foo. This is the property that I've got into vault, or the place, and the property my value, and put it as a foo bar. So now if I apply this, and demo gods are with me, which is another thing, I run it. See that the secret is foo bar. So now if I do get secret, I've got here the example sync. This is, it's here. The target is example sync. And if I do, you see that 6 seconds ago I created. And if I do a get secret, this secret minus O YAML, you see that I've got just a secret, Kubernetes secret, but with the data foo bar and the, in this case, and the value. And remember that this value is in base 64. Okay, so I didn't have this secret, and just by applying these two YAML files, the secret was never revealed. Okay, it's always there, but it's in bold. So when I apply these YAML files, I just get this secret and put it into the Kubernetes cluster. Now, this is the easiest part, right? Well, if it works, but it's the easiest part. Now let's go with the hard thing, the part of Oppenheimer, which is encryption data at rest. Because here we are just having two strategies for storing correctly secrets into Git. But what's happened when you are not in Git? You are out of Git, and now you're into the Kubernetes. Oh, first thing, etcd is not encrypted. Remember that all the secrets and all the objects of Kubernetes are stored in etcd, which is a database. And by default, etcd is not encrypted, which means that you can store there a secret. Remember, in base 64, because when you apply any of the techniques that I showed you before, it creates a Kubernetes secret, which at the end is in base 64. So anyone with access to etcd, get the secret. Anyone who has access to the logs of the etcd can get the secret. Anyone who has the backup of the etcd, it gets the secret. So, okay, it's not very, secret at all. And this is well known by the Kubernetes community and says, oh, yeah, no worries. We're going to create an encryption configuration object that basically, when you apply a Kubernetes secret, we're going to encrypt this secret and then store it into etcd. So basically, you apply a secret, then you have the encryption configuration object that apply it, then it will encrypt the secret and store in etcd encrypted. And when you want to apply this secret into a pod, it will be the reverse. So it will get the secret from etcd that it's encrypted, it will decrypt it, and inject it into a pod. And you might say, oh, yes, this is what we are doing. Yeah. The problem is that, keep in mind that you're storing the secret and the private key to encrypt or to decrypt the secret in the same machine, in the same node, because it's etcd who stores the private key. So anyone with access to etcd can get the private key, can get the secret, and decrypt it. So it works, yes. It might be fine for you, yes, but just keep in mind that there are some problems if you do it in this way. Possible solutions. Well, the first one is moving etcd out of the Kubernetes cluster. This is something that is supported by Kubernetes. You can just take the etcd, move it outside the Kubernetes cluster, and it works. In this way, what's happened is that you've got like two places, right? In one place, you've got the secrets, and in another place, you've got the private keys. So an attacker might need to compromise two systems. Although this is a possible solution, it's something that we usually do not recommend, and we recommend more using the KAMS plugin. Okay, that basically it's, I've got a secret. Okay, I just get the secret. I want to apply it to etcd, so I go to an external system, an external secret management system. For example, Vault. You can just connect to Vault and say, hey, this is a secret. Please encrypt it. It encrypts the secret and it gets back. And then it stores to etcd, which is inside the Kubernetes cluster. And for consuming the secrets, it's the same thing, but in the reverse order. In this way, an attacker might need to compromise two systems. Might need to compromise etcd, and might need to compromise Vault. it compromises Vault only, okay, you've got the private keys, but you do not have the secrets. If you compromise Kubernetes etcd database, okay, you've got the secrets, but you don't have the keys. So it's a really good strategy to have this. As I said at the beginning of this session, if you're managing with just encryption configuration object and you're not using this approach and always work, just continue with it. If it's fine for you, it's fine for me. But just keep in mind that you're putting both the private key and the secrets in the same machine. But it's even more things there because, okay, you can have your secrets encrypted inside etcd. So you said, okay, etcd is okay, it's encrypted. In Git, they are encrypted. In Vault, they are encrypted. We're fine. Well, the problem is how we inject these secrets into the pods. And basically, there are like 3 possible solutions. The first one, as an environment variable. You can inject secrets as an environment variable into a pod. Yeah, a lot of things doing in this way, which is fine. But you know that if someone accesses this pod, can do an export and get the secrets. Or also there is a lot of logging systems that at the beginning of the pod logs the environment variables. So it means that in your log system, you will have the secrets exposed. And in plain text, so if this log system is attacked or the backups of this log system is attacked, whatever, you will have the passwords there in plain. Another option would say, oh, no, yes, but we are doing as a volume, which is better because as a volume, it means that you created a file into the pod. It's better because a log system will never expose the secret, but any attacker could access to the pod and just do an fstab, get all the mounted file systems, get the secret, and just see where is the directory, what is the values, because they are stored in plain text, and get those values. So it's more secure than environment variables, yes, but, okay, yeah, still some problems. Another way is using directly the Kubernetes API. So basically it's saying, I don't want to inject secret directly into my pod. I'm going to use the Kubernetes API to get the secret. So I'm doing an HTTPS call to the cluster itself and get the information. And works. Probably it's the most secure of these 3, but you will need to write more and more YAMLs because you need to configure the role binding, the roles, and there's a lot of things to configure to be able to get this. So maybe it's not the best way. But I have an idea, which is basically using a key management system or a secret management system. I'm always focused on Vault because it's open source, and you can always download it and install it and start playing, okay? But it works in the same way. Basically, it's having your pods in some nodes, some of your Kubernetes nodes, and then you have a node where you've got Vault, where you store directly all your secrets, okay? And then what you want to do is just do a connection between your pod and your secret management system and consume the secrets from there. This is the most secure way because basically your secret is just transmitted using HTTPS from Vault into your application. And then when it's inside your application, it's stored in memory. So there is no file, no environment variable, nothing. It's just in memory. So if any attacker gets access to your pod, of course, they can dump the memory. But yeah, it's like, trying to find what is the password. It's super hard. But apart from that, your password or your secret is secure because it's not as a file system, it's not mounted as a file system, it's not injected as an environment variable. Of course, using this approach has good things, bad things, and they're ugly. Basically, when you start using a secret management system, there is a new tool that you need to learn. You need to learn how to operate, understand how it works, okay? Understand that maybe the first time you're not going to secure it perfectly, okay? But it has other thing that it has been created for storing, for keeping your secrets secure. Another problem is that, as you've seen, it requires that your application changes. Because now you're doing an HTTPS request to an external system, get the secret, and store the secret. This means that you need to change your code. It's not like, OK, now I've got my brownfield application there, and I'm just going to start using Vault. Yeah, it's not going to work, because you still need to change the code. So it's a possible solution that works for greenfield projects, maybe for brownfield projects, not that much. But as I said, they are the best. They are created for storing correctly your secrets. But it's not only this. Usually, they also have some kind of monitoring system for detecting attacks. So any attack, someone that has should not be able to get access to the secret, if tries, it will raise some alarms, and then you will always be able to block any communication from that IP or whatever. So that's the great thing about these toolings. Let me show you one example of using Vault and the systems that they have. Let me go, well, like here. Okay, and here, this is Kubernetes. Okay, I've got my application here. This is a welcome message, name generator. This is Vault, and this is PostgreSQL. Basically, what I'm just doing here is that welcome message calls name generator, okay, to get some name. Then welcome message also connects to PostgreSQL database to get some information, basically the name, and then it shows you the name. It's super, super simple. You can see here that I can do a refresh, and you say hola bor, or you can still, you see that these different languages and different names. Okay, the languages comes from the database. Okay, now, when Joanna, for example, when you comes from the database, what is the key point here? You will say, okay, it's just an application. The key point here is that if I go to here, this is the configuration of my service. This is the important things here is this one. And you see that there is no username or password. Okay? Where is the username and password? In Vault. But it's even more important. It's why there is nothing here of a username and password if they are involved. It means that I have created manually, and the answer is not. I'm using one of the great things about Vault, which is dynamic passwords. Basically, it means that the best secret is no secret. So if there is no secret, no one can steal your secret. So with Vault, I'm configuring saying, hey, there is a PostgreSQL database, which is in this host, okay? And every 30 minutes, renew the password. But I will never know the password. It's auto-generated password. So from the point of view of the application, no username. Oh, yeah, username, yes, is admin in this case, but it doesn't matter. And there's a password. Password is not here. And every 30 minutes, the password is being renewed. So I never know the password because it's managed automatically by Vault, and Vault automatically promotes this new password to the application. Okay, so it's a really convenient way of dealing with passwords with a database. So let's wind down, because I would like to have like 10 minutes or so. Come on. I want to have 10 minutes for questions. So just keep in mind that here I explained you a lot of things, but all these things might work together. For example, you might need sales secrets or external secrets for storing your secrets in Git. Maybe you need KMS plugin, because at the end, you still need to store these secrets, so you need to encrypt them in the etcd. Then we've got the problem of how you inject these secrets into the application. Probably the best way will be, as I said, having no secrets, or if it's not possible, having some kind of secret management system and access directly the secret management system and store the secrets into memory. But again, you might say, there is always a secret, right? Because there is a secret that you need to keep, right? For example, for accessing secret management system. In case of Vault, it's quite different, okay? Because even for accessing Vault, you do not need to have a secret if you are into the Kubernetes. But in any case, you can always get this chicken egg problem. That is like, okay, at the end, I need one secret. Sometimes you need it. Then maybe you need the KMS plugin. So basically, you need a view of all these techniques. As as a conclusion, there is no bad or good or bad approach. I just explained to you some of how Kubernetes secrets are managed in Kubernetes. I explained the problems, possible solutions. But again, don't get crazy saying, hey, I'm going to start adopting HashiCorp Vault now. It's not necessary. If it works, have you been doing? It's fine. But if you are saying, oh, yes, we've been doing in this way, but I think that it will be better to change these things, then this talk, I think that it's perfect for you. Super important, key secrets and key rotation. At the very end, yeah, it can happen, right, that someone lose the password, whatever, or the secret. What is important is rotate the secrets and the keys pretty often, maybe every 15 minutes, or maybe 30 minutes, okay? Just doing a renew system. With HashiCorp Vault, it's super easy. You can just code that, just say, hey, every 30 minutes renew it, and it will renew, and just communicate with the application, and just change the password to access the database. But it's super important to have these rotations. Tools like Falco, StackRox, Snyk helps you a lot of detecting possible vulnerabilities of your system. As I said, no secrets is the best secret. Okay, so just try to use the HashiCorp Vault dynamic secrets as much as possible, because it will help you a lot, right, on not having to manage secrets, because it's managed by an automatic system. And again, you might need always a Kubernetes secret object as well. As I said, this is the chicken egg problem. Maybe you need a username and password to start accessing all these components. So at the very end, you also need to know how to manage them into Kubernetes. And as I said, I'm the co-author of these two books. One is Securing Kubernetes Secrets. The other one is GitOps Cookbook. In both, we are covering some of secrets, how to manage secrets. The GitOps Cookbook can be downloaded for free in this QR code. So if you go to this QR code, you need to register to developers.redhat.com, but it's free. And then you will be able to download the book. And I explain some of the things that we've seen here. And if you want to go deep to more and more examples of, for example, OK, I'm using, I don't know, Amazon Secret Management System, how I can do similar things like we are doing in Vault, but in the Amazon, then Securing Kubernetes Secrets, we cover these topics. And this is the links of the slides, the code, for the codebook, and so on. And that's all. I think you still have, well, it's 1 minute from the scheduled time and 7 minutes for that. So if there is any question, I think that, yeah, Ricard will...
There are many questions.
How many?
First of all, please keep it quiet, because yesterday there was a lot of noise. There are many questions. I'll try to group them again. It's impossible to ask them all, but the most liked one is if you can explain a little bit more how to authenticate against Vault in the most secure manner.
Yeah, well, that's what I was mentioning of the chicken egg problem, okay? In case if you're running Vault and applications into Kubernetes, there is the Kubernetes authentication process, which basically you need to configure all the Kubernetes, right, and all the raw systems, so your pod knows that it's running in a Kubernetes that has been certified to be the real one, and it's the one which are running by Vault, and then you do not need to authenticate at all. I mean, yes, it's authenticated, but it's happened under the cover, okay? So you do not need to worry. If not, there are a lot of systems. One of the love is the one that it's used for detecting that only one system can lock and retrieve a secret. Okay. Basically, what you're doing this is like, okay, I've got my pod. This pod needs to consume a secret. Okay, I'm going to consume the secret, and then it has an internal counter saying this secret has been consumed. Then, if any attacker tries to consume the secret, it will say, oh no, you cannot consume the secret because it has been already consumed. Okay, then this, you authenticate using this way. There's other ways, like for example, with MAC address. So you can say, hey, only this MAC address can connect to Vault. There is a lot of authentication methods there. I would say that if you're in Kubernetes, just go with the Kubernetes authentication method.
Okay. You have talked a lot about Vault, but obviously there are other ways to store secrets and stuff like that. one of the main questions is like, okay, imagine you're using external secrets, right? But instead of using Vault, which is, there's no charge, you're using some of the cloud offerings, right? Like Secrets Manager, Parameter Store, or the likes of Azure, Google Cloud, whatever. So, and of course, these things cost money. Can you tell them more or less how to mitigate this cost? Because obviously, if you have tons of secrets and constant updating, it can become pricey.
Yeah, well, at the end, you can configure external secrets. The time of refreshing the secrets, right? You can put 30 minutes, or you can put 1 hour, 24 hours, or whatever, right? So, of course, if you got too many secrets, then you cannot do. You can reduce secrets, but it's your application. It requires the secrets that it requires. But with external secrets, you configure the refreshal time, so you can put maybe 1 per month.
And now let's talk about a bit of resilience of Vault, right? So imagine the Vault node crashes and the secrets were in memory. So I guess the recommendation is to scale it out, have multiple replicas. That's what you should do, right?
Yeah, then it's like, okay, with Vault, you can replicate and create replicas of it. Of course, it's also important to know that, meanwhile, the change doesn't, if the secret doesn't change, it doesn't matter if Vault is down. Because you just consume the secret, you put it in memory, in the memory space of your application, and that's all the things that you do, right? So if Vault is down, okay, you've got your secret in memory. The problem is what's happened if the secret changes. Then, yes, then you might have some problems. But usually, this is not a big issue.
Okay, now imagine you have a breach and some attacker has access to the pod, right? In that case, Vault, would it help mitigate that? Or once it's in the pod, it's more or less authenticated, right?
Vault will help you because the secret will be in the memory space, which is better than having in file or as an environment variable. So let's say that, of course, the secret is in memory, but it's super hard to get the secret, right? It mitigates in this way. But in any case, if some attacker gets access to the pod, I think that you've got a bigger problem than having to know if, the secrets and so on. So,
Okay, so about sealed secrets, okay? They're asking, where's the private key stored, effectively?
Yeah, the private key is stored into this controller. I think that you can configure where they are stored. But, of course, it's a private key that is in node. If someone accesses that node, for example, if it's stored as Kubernetes secrets, then access to the etcd, then they can get that private key. For the reason I said, that it's really important to have an overview of all, not only how you protect the secrets in Git, but also how to protect the secrets into the cluster.
And also, I'm curious about this one. Do you know if there is a way, I think there's not, but to inject secrets only in memory, aside from, of course, the pod calling or being notified?
No.
That's only, mvars or volume mounts, right, mostly?
Yeah, but when you inject as a volume, you're creating a file that is an in-memory file. So you are putting in memory. But as I said, if you have access to the pod, you do a fstop, and you get the volume mounted there, and you can get it. So,
And I think I'll ask the last one because there are so many that it's impossible to fit. They're asking about, at the very beginning, you mentioned the Git delete secrets.
Sorry?
The Git delete secrets. At the very beginning of the presentation, you spoke about Git deleting secrets or something like that.
Git delete?
Well, they're asking, does the original Git delete secrets process also delete Git history?
Well, you're saying, So you're saying that what's happening if you push a secret into Git, and then it takes care of the stuff. There is some kind of ways to just remove this. I don't know exactly, but there is some kind of low-level commands that let you remove this file without leaving there in the history. Another option, I think that it works, but again, if it happens you will need to stop all the development. And what I will recommend maybe is just do stop development, no one pushes anything, do a squash of the commits, and then ask to everyone to do a pull. You are rewriting the history, so it's quite dangerous. But if you do in a controlled way, it might also be possible.
And just to finish up, can you disclose why it's better to have Vault internally in your cluster versus having an external dependency like Secrets Manager or Parameter Store?
As I said, I'm just using Vault because it's an open source project, and you can just built on your, you can go up after the talk and start using it. But it depends on if you want more on-prem or if you trust in cloud. Yeah, sometimes some organizations prefer on-prem, others cloud, it's fine. Yeah, but it's not better or not. It's just a matter of having the demo that all of you can run it on your cluster.
Okay, so we are literally out of time. Thanks a lot, Alex, for coming back again. Thanks a lot for sharing this talk, because it's really important to do it securely. Thank you.
Thank you.
All right.